You guys think the Beastie Boys that?
Yeah, an hour. You guys get an hour, right?
Yep.
No, we don't.
20-minute peak train.
18 minutes total, move.
Okay. Done. Okay. We ready? Or do we still need to test? Yeah? Good? Okay. I'm James Tunick.
I'm Houston Riley.
And our thesis project is called CINE, spelled C-I-N-E, and it stands for Collaborative Immersive Network Environment. And the basic crux of our thesis is that we believe current computer design, interface design, and screen design inhibits collaboration and expression, especially in large groups. We feel that the concept of the computer as an object is a dated concept and something that needs to be broken out into the physical space. We feel that the mouse and the keyboard and the interaction involved in most personal computers, first of all, it is a personal computer, it is a single user experience. Also, the interaction is limited only to the movement of the fingers and of the wrist. And we feel that by breaking the interface and the screen out of the box and into the physical space and allowing users to use things like gesture and their physical body movements will really allow a greater range of expression and new types of collaboration to develop. So that's kind of the major idea behind CINE, is this immersive environment where multiple users can use gesture to navigate through a 3D image space. So to give you a little bit more of a detailed overview of what CINE is exactly, it's actually a mixed media space, a mixed reality space, where there are users both in the real world, on the city streets, taking pictures with mobile devices and cell phones, and those pictures are then sent to the immersive environment, where multiple users can grab those images and place them on the sides of virtual buildings, as if it's kind of their own personal Times Square. And it's this idea of shared control and mixture of virtual and real. So that's kind of the basic idea behind CINE. Our major inspiration, and probably the closest example to what CINE is the cave environment. And the cave is a totally immersive environment using 6 screens. The crucial difference is that the cave is often over $1 million, and it also only tracks a single user at any given time. CINE costs in the range of about $30,000 and can track multiple users in the space at once. So we'll discuss a few more of our inspirations. Excuse me for one moment. Could be important. There we go. So several of our other inspirations besides the cave environment are the film Minority Report, and this has been a real kind of guiding light for us and an inspiration in that we feel that it provides a very accurate vision of what the future of interaction with computing spaces will look like. In this scene, Tom Cruise reaches out and grabs images physically with his hands, moving them across the screen, removing the idea of the mouse and the keyboard almost completely. There's a direct connection between the user's body and the information that the user is trying to manipulate. The interface is totally transparent. There's a very, very direct and engaging interaction going on here. Also, you can see the screens are immersive. It's a curved display. 2 people can work in the environment at once. And we think that this is a very important model for the future of computing environments. As space, again, as something that moves away from the idea of the computer and the interface as object. Another important example that we've been looking at this semester is the REV system, which was developed by the Digital Worlds Institute at the University of Florida. This is an immersive theater where 140 students can sit. And what's most impressive about this system is not that it's immersive, but more that all the people in the classroom can participate in this environment at once. Every single person sitting in the audience has a digital piece of chalk where they can reach out, they can take notes, they can ask questions. while still kind of retaining this big picture view. And I think that in the future, education would be much benefited by immersive technologies that allow participation in ways that allow huge groups of people to participate at the same time. The digital chalk, essentially, I believe people have lasers, and they can reach out and basically, point at things on the screen. They also, with their laptops, they can ask questions, so everybody is able to participate at the same time. And again, the idea is that you don't have people falling asleep in the back. Everybody feels like they're participating. Everybody can be addressed by the teacher. The teacher knows exactly who each user is. And so it really makes for a much more engaging participatory classroom experience.
Not so sure.
No?
Who said that?
We knew that was coming.
We cut into the time.
So, another one of our major inspirations is the holodeck from Star Trek. Some of you may be familiar with. Is an entire room that's immersive. All screens are filled with graphics, and again, the idea is that multiple users can walk into this space. They can decide they want to be in the desert, they can be on the ocean, they can be in a rainforest. And again, the idea is that the whole space can transform at the snap of a finger, and that multiple people can experience this computing space at any given time. Again, getting away from the idea of this tiny little screen that only allows a single user to interact with the information at once. I think another important example is in gaming with the Xbox Live. And this particular example is interesting to us mostly because it's networked. We feel that massive multiplayer online games and Xbox Live are a great example of some of the ways in which interactive 3D will involve different networking abilities and allow people from all over the world to collaborate in the same computing space at once, whether physically present or virtually present. Another key example for us that is also a gaming environment, but it's kind of multimodal, is a system called Muse, being developed by several people from Take-Two Games. And essentially, this is an immersive, interactive 3D experience, mostly for online use. Allows you to see multiple web pages in a single view. You can see other avatars, other users floating in space. People can choose what they want their avatar to look like, so suddenly they can alter their identity in these virtual spaces. This actually looks like a human. Some of the other avatars look more like aliens and creatures, and you can kind of choose the identity that you want to assume in this space. Also different ideas for collaborative data visualization for the stock market, interactive 3D desktop applications that allow multiple users to interact with it at once, and an interactive gallery experience. The next example is an interactive 3D application that Miro Kirov has been working on for the last several years at the NYU Medical Center. I'll let him explain in a little more detail how virtual patient works.
Thank you, James. So, talking about the virtual patient, 3D, unlike Craig, I like anything 3D. I like things presented spatially. So, I've been working on this project for a few years, and the idea came up really with increasing need for the students, medical students, to experience together with the patient in the hospital and advance their study. Why? Because the hospitals are quite different than they used to be 20 years ago. So if you think everything has changed, the technology is advanced. So the process is much shorter. If you think like diagnosis, from diagnosis to surgical procedures and then recovery process, everything is much shorter. So the student has no time to interact with the patient and learn. So that's where technology comes to help. And there is virtual patient. All the organs are built, and you can fly through the body and take annotations, take screenshots. Also, it's collaborative. It's on the net, so you can save your data to the server and talk to your colleagues or to your students, fellow students, so you can change data and So Houston will continue with our presentation.
Thank you, Miro. I'd like to talk a little bit about a few more of our inspirations. One being getting away from the antiquated file and folder storage technique in the desktop OS that might be applicable for CINE is Project Looking Glass. And it provides a multi-planar view. It gets away from the old two-dimensional desktop, which we loved, and thought it provided for easier navigation through the system. It could be used for file visualization, file storage, file sharing. That comes courtesy of sun.com. Below that is an interactive flash demo that we see as an information map. And you can see at the bottom of the top image, it has a timeline, and it's timeline based. And each of the different colors represents a different piece of the infrastructure in urban infrastructure and urban planning. We see this as an invaluable tool for urban planning and development and architecture. And currently World Oil is using a similar scheme. And then as we continue on, we see another application as an urban info space. MIT Media Lab has created City of News, where three-dimensionally you're visualizing data, files, images. And we see this as spatial recognition, and the visual integration allows for, we think, greater memory of where files are and how files are organized. And if we continue down, we see more practical applications such as a database, which is exhibited by the Millennium Project, and then another previous project by Miro and James. And we see all of these as applications, but we're not limited to these applications. We also see, in addition to urban planning and development and architecture, education, gaming, television, you see all of these different inspirations. We also see music composition and collaboration. Anything else to add? Retail, storefronts, pretty much endless if you really wanted to get right down to it. And I think now James will speak about some of the technical aspects.
And so now we've spoken a lot about our background and our inspirations in this project, and now we'll speak in a little bit more detail about some of the technical details. So it's something that we concentrated really hard on throughout the last year. We've been doing research for this project for just over a year now. And we began thinking about ways in which you can track multiple people within a computing space. And we started by looking at different video tracking techniques such as color tracking, motion tracking, mostly through Max MSP and Jitter. And what we found was that inside of immersive environments, there's always changing lighting because of the projections, you know, whether it's rear projected, whether it's front projected, there are ways around it. For instance, you know, if you light up the whole floor and you track dark blobs, that's one way to use video tracking, but it's very hard to track multiple users with video tracking in an immersive environment where the lighting conditions are always changing. So what we found was that infrared sensors were the best way to go, and this also kind of got towards our goal of lowering the cost of gesture tracking within immersive environments. We found $8 IR sensors on the net, and we embedded those sensors inside of a crystal ball interface. Now, the reason that we chose this crystal ball as our main gesture interface was that one of our major goals, I think I failed to mention in the opening, was really to inspire a sense of magic in this environment and give people the feeling that they're, you know, immersed in this futuristic world and that they almost have superhuman powers within the environment. You know, people are so taken by these visions in movies like Minority Report and, you know, Harry Potter and all these movies just show people doing these amazing superhuman things. Why not design interfaces and technologies that inspire people in the same way and really spark the imagination? And so we designed this crystal ball interface that has embedded IR sensors, and beyond kind of wanting to inspire a sense of magic in our users, another reason that we use this is because we knew that people would come to this interface with a preconceived notion of how it's supposed to work. We knew that people had seen these in movies, they had read books about it, so they knew, you know, vaguely that they had to move their hands over the crystal ball in order to get it to work. So this is the basic design, or the sensor layout. So several of the sensors are embedded in the crystal ball, and several of the sensors are also mounted within the screen. So there are 3 sensors within the screens, and there are 6 sensors embedded inside of the crystal ball. And the IR sensors that are on the screens control the scrolling through the images that are coming in from cell phone world. And the sensors within the crystal ball control the navigation through the virtual space. And from there, I'll let Houston explain our kind of overall system diagram.
Yeah, as James said, I'll talk a little more about some technical details. We're using infrared sensors and then sending our analog data to the PIC chip in our analog interface, which is Telio, made by Making Things, and then into Cycling 74's Max MSP on the Mac laptop. The MIDI is then sent through 2 daisy chain 2x2s. Then it goes into the PC desktop into Virtuals, which then is translated into the 3D navigation through the virtual world. That is transmitted to 3 backlit projectors, or 3 rear projectors, and all the while dynamically downloading parsed images from the web using Perl script. And then below that we have our CINE system architecture, which gives you the software architecture in a little more detail. And I think that Miro will talk about Max and Virtuals.
Yes. Talking about the applications, we came up with 2 main applications, Max MSP and Virtuals, and they're both very powerful and very similar in a way, but also very different. The similarities, of course, they're both object-oriented, and as well they have, you can create a network, web of network between the objects and very, complex interaction. But Virtuals is great for, it's a game engine, and it's great for virtual reality environments, while Max MSP is great for massaging data and sending it to other applications and communicating between computers. Another attractive thing to us was that Virtuals came up with the VR pack, which can make a cluster of computers, putting them together, so that you can have like multiple displays, very much like the cave environment, and but much lower cost. We had a display at the Chelsea Museum art show, and we were using Matrox card, but unfortunately Matrox card has 3 displays, and you can and it's kind of lowers the refresh rate. It divides the refresh rate between the 3 displays. So if you have 60 frames per second refresh rate, it goes to 20 frames per second for each display. While if you have clustering computers, the refresh rate is great, and it's the same like in short. So a little bit on the process of building the 3D. I used Maya. First we came up with the idea of using the map of New York, and then we traced in Maya the whole map, and then extruded the buildings. We wanted to keep them very minimalistic and very simple, because it's a very complex shape. So James will continue with the presentation.
Okay, I think we're running a little low on time, so I'll skip through a lot of our sketches and photos of our process, and I'll go straight to a 1-minute video clip, and then we'll lead you on to the other room where we have a quick demo. So, as Miro mentioned, CINE was featured in a show called the Interactive Multimedia Culture Expo at the Chelsea Art Museum a couple weeks ago. I'll pass these out to people. And the show was covered by New York One, so we'll show a quick video clip of that. And unfortunately, they got ITP's name slightly wrong, and I sent them an email telling them please to correct it on the website, so I'm hoping they will do that soon.
An entire exhibit of high-tech art that you can touch, change, interact with, yet they're all longing for a life outside of museums. This is the 2nd annual Interactive Multimedia Culture Expo, developed by Studio IMC and the NYU School of Interactive Telecommunication.
It's a hybrid trade show and art show that is meant to expose the future of interactive new media in the arts, entertainment, and retail. So many of the artworks in the show double as commercial products. Many of the works can be used in architecture, for example, in window displays and storefronts.
CINE takes the future of computing straight out of the movie Minority Report.
You use gesture around the org to navigate the camera in different directions within the virtual space, and also to key certain sounds. It has various embedded IR sensors, it's infrared, and so the idea is basically that, you know, it's shining infrared light off of the hands that are around it, and it basically sends a number back to the computer.
Now this one behind me is a piece of artwork called Freestyle Eyes.
Okay, and now we will bring everybody into the other room. You can bear with me for 1 minute. Take your time. It'll take us 1 minute to set up in there.
We have no mic in there.
Oh shit, only the camera. Can we take this in? What can we do? But it's muted.
You have the sound?
So as you can see, Miro is controlling the environment using his gesture. He's zooming out now with the sensor in front. Now he's zooming in and turning to the side. And as Houston will demonstrate, he can scroll through the images that are coming in from cell phones and other mobile devices using gesture, and then he can choose one of the images once we're zoomed in far enough and apply it to one of the building sides. Again, the city kind of becomes your own personal Times Square in this way. You can see the various landmarks around New York. There's a picture from my bedroom. This is, there are pictures of Central Park. Can I give it a quick try, Miro? Zoom us out a little here. And apologize for the front projection. Ideally, this environment would be on 3 to 4 walls. It would also be rear projected, so you wouldn't see any of the shadows here. So again, the idea is this would be much more immersive. This is a much smaller scale version of it. We just wanted to kind of show in general how it works. So you can see each sensor actually corresponds to a sound as well. So the closer I get to the sensor, the louder that sound will become, and the faster the camera will move through the virtual space. So I can lift us up, I can bring us down, I can zoom us out so we have a fuller view. And again, even though the projections don't allow multiple people to be around the crystal ball at any given time, the idea is that, 2 or 3 people could be around the crystal ball at once. One person standing over by the scroller, and obviously you wouldn't see my shadows here either on a larger scale. And again, the idea was really to inspire a sense of magic in this world, and it's also something we feel like, it's not only an installation that could be put in a museum, it could also be used in a window display, it could also be used by an architect, by an urban planner, by an educator. We really feel like there are a lot of possible applications for this, and once we graduate from ITP, we're going to continue developing the CINE concept through the company we've all been working with, Studio IMC, and we're in conversations with a number of companies about marketing this and developing it further. So if anybody has any ideas or leads for us, we'd definitely appreciate talking to you once graduation is over.
And special thanks to Frank and John Mark.
Right. Frank and John Mark, who are great supporters of this project and really led us through. So, thank you.
Thanks, guys.
I think we're over.